watching The Morning Show from your local news leader.
Well, it's been a pretty unique January.
A lot more humid than expected. But why exactly is that? Matt Stellan, U of I physics professor, joins us today for our Wise Guys Wednesday. All right, I see some haziness happening here.
Right, so we're going to make some fog and some clouds. But first, I want to just talk about humidity just a little bit, because it's interesting. Because the air that we breathe, we all know contains oxygen, because that's how we live, and it contains nitrogen. That's sort of the gas that makes up most of the air. But it also contains water and other gases as well, of course. And water is an interesting gas, because we think of water as being a liquid. But if you put a glass of water on the counter and you leave it there to the next day, it'll be gone, because it's evaporated. Right? And so water goes into the air, and what's sort of interesting is that the amount of water that's in the air generally depends on the temperature. And so, in fact, something called the maximum amount of water that can be absorbed into the air and still be a gas increases with temperature. It can be quite a lot at a high temperature and very little at a low temperature. Okay, so relative humidity is an interesting concept, so we have to talk about that. So suppose this is how much water can be absorbed in the air, and suppose this is how much is absorbed in the air, sort of halfway up. That would be 50% relative humidity. So that means that if you put a glass of water on the counter, and if it was only 50% relative humidity in the air, which is sort of normal, then that evaporates. But if you have 100% humidity, you know, in the summer where it's muggy and hot, if you put a glass of water there, it might not evaporate at all. Okay? And so if you have more and more water in the air, and so that the maximum is equal to what you actually have, you don't get evaporation anymore. But if you have only half as much water as you can have, then you will have evaporation. So suppose you have warm, moist air, and you cool it down. That means it can hold less and less air, and eventually you'll get to a temperature at which it has 100% relative humidity, just because you cooled it off and it can't hold as much water anymore. That's called the dew point. So we're doing a weather thing here. Okay.
Adam.
All right.
Adam.
So what's interesting is you can have hot, moist air or warm, moist air, like what comes out of my lungs, okay, because my body's warm. My glasses are cooler than my body. And if you go like that, you get steam on your glasses. That's because the air that comes out of my lungs is warm and moist, but the glasses are colder, and when the air gets as cold down to the temperature of the glasses, it can't hold the moisture anymore, and it condenses. So in this thing right here, there is liquid nitrogen sitting at the bottom. It's just a liquid. And so the air that's in this thing is very, very cold. So we're going to do the glasses experiment, except you're going to blow your breath into this thing.
Oh.
Okay? So what's happening here is that warm, moist air comes out of your lungs. Do it again. Okay? And that moisture condenses because in here, this is very cold. Cold air cannot hold much moisture at all. And so when the air contains the moisture, it's invisible, but when it condenses out into little droplets, it becomes visible. Okay, so that is how clouds are formed. It's when you have warm, moist air down near the ground, rises up, and it cools off, and eventually it gets to the temperature where it can't hold on to its moisture anymore, and little droplets will form on little specks of dust. Okay, so what we're going to do right here.
Man, I feel like a meteorologist. Who's Adam?
I'm going to pour hot water into this vase. Sorry, I'm making a little bit of a mess, but that's what I do. Okay, and I'm just doing this so that I get this thing nice and warm. And so inside this thing now is warm, moist water. And I'm just going to make sure this thing is all warmed up. I'm going to pour most of it out into, just get it out of the way, into here. Okay, so now we have still warm, moist air above the water. It's warm in there. Now we're going to put a little dust inside of this thing. And instead of dust, I'm going to use a little bit of smoke from this match. I'm going to hold it right here and drop it in. That's going to give just enough little tiny particles for the cloud to form on. And now I'm going to put a cold thing, which is this bag of ice, in the top of this. And then we're going to zoom in, and we're going to see what starts to happen inside of this thing.
Well.
So you have a little condensation on the inside, but you will also have, let me scroll that around so that the condensation goes away. Well, you see how there's sort of the vapor coming down from the cold thing? So it's forming a cloud in there. So you can actually see where up at the top where it's cold and the moist air meets the cold ice, you see a little sort of rivulets of moisture droplets forming. And if we leave this thing for a while here, what's going to happen is that this thing is going to just sort of fill up with a cloud.
Oh.
So you can try this at home, because I know you can't do liquid nitrogen at home.
Why
Because
can't
you
you?
don't have the stuff. Well, you could if you came and borrowed some from me. But this is an experiment you can do at home. You just have to be a little careful with the boiling hot water, but ice is pretty fun to play with.
Wow.
Okay, and
Even
so
when you did that, you saw it all kind of
Yeah.
come back up.
yeah, so you can see right now, you see how the condensation is forming on the side, just because here the warm air is coming out and is meeting up with the cooler air out here. In fact, this is sort of how a cloud forms. So you have warm, moist air coming up. Out here, the air is cooler. And so the air out here cannot hold as much moisture as the air in there can. So you see the sort of the vapor forming, and clouds would form if this was, you know, up in the sky and you had cubic miles of this stuff. And so moisture is important for us to be comfortable. That's the last thing to realize, which is that how are we doing on time here?
We're okay.
We're okay, good. I know you were looking, so I get a little worried. So it turns out that the way our bodies regulate temperature, the thing that makes us comfortable, is that if we're a little bit too warm, we sweat a little moisture evaporates from our skin. And so that is, our body's ability to do that is one of the things that makes us feel comfortable. And so if you have 100% humidity, water cannot evaporate from your skin, and you're very uncomfortable in the summer, like when it's hot and muggy out. If it's too dry, your skin will crack, and things, you know, it's a bit uncomfortable too, but right around 50% relative humidity is where our body feels comfortable. So that's, if you have in the wintertime, if you have a humidifier in your house, you set it to like 40 or 50%. And so that's that's the way those things work. Sometimes they just boil water and make water go into your room.
Matt Sellen.
So interesting.
As always, it's been fun. We'll be right back with more of the morning show.